16 most used data preprocessing techniques in next 20 minutes. Let's see in this video. I will be showing you all the preprocessing techniques through demo in this video, and all these techniques will primarily fall into 5 major situations. So one situation could be situation of a missing data, other situation could be situation of outliers, and so on and so forth. But for doing all this, first of all, we need a data. That is what I'm going to do here. I'm going to create a small data set. As you can see here, age, salary, purchased, gender, and city. I'm creating a small data here. I have put inside a function and I'm calling that function here, and my data gets created. So this is my data. As you can see here, age is one column, salary is another column, purchased is one column, gender is another column, and city is another column. So I reran that. So it's rerunning. Let's wait for it to finish. It finished. Now let's go to the situations one by one. When you work with data, then you can have a situation where you have a missing data. What can you do in this situation? What are the different things you can do? And what are the pros and cons of these? So to know that, first of all, let us introduce some missing information in this data. What I'm doing, I'm just inserting a np.nan in age column and salary column. When I do that, you will see that some nan is getting inserted in age column, and one location in salary column also it is getting introduced, okay, on the 10th index number. So now we have missing data here. What are the different things that we can do, and what are the pros and cons? Let's see that. First of all, simple imputation is that you can do. What is the meaning of simple imputation? This missing data can be imputed with either mean, median, or mode of this particular column. And what are the pros and cons of this? Pros is it is fast and straightforward, and con is it may introduce bias if missing data isn't random. Now here I am writing missing data isn't random. I have created a very detailed video on this topic at Unfold Data Science. You can simply go to YouTube and search Unfold Data Science Missing Data Treatment. There I have explained what are different ways in which data can be missing, what are different ways to work in those situations, and so on and so forth. But one category of data being missing is data being missing random or not random. Here I am saying it will introduce bias if data is not missing at random. If there is a reason for data being missed, right, and you are doing a simple imputation, that can be problematic. But the thing here is it's fast, easy, simple, and straightforward. You simply go and fill NA with mean. You simply go and fill NA with median, and your problem of missing data is gone. So if I run this, you will see that NaN is gone and there is a data here. Okay. So that is what you do when you have missing data, and these are the pros and cons. First way. Second way is list-wise deletion. What is the meaning of list-wise deletion is wherever I see a NA, that complete row I will delete from the data. So for example, if my data has 10 rows and in one row, one record, there is NaN, right? I will completely remove that row. This is called list-wise deletion. What are pros and cons? Pros is simple, con is losing data. So you are basically losing data. That record will completely be dropped. So what you will do, you will simply lose the data. Now, what we can do, we can again introduce some NaN in the data just for demo purpose. And here what we can do is you can simply say drop NA and it will do the list-wise deletion. But the size of this DF dropped will be different than size of DF. So as I told you, the data size will decrease. So 18 rows here, and originally if you see here, right, there will be more rows. For example, here if you say df.shape, right, you will see more rows here. So let me recreate the data and I will show you. For example, df.head we are seeing, and we can also see df.shape. This is the original data, right? So previously we are having 20 rows, but we deleted list-wise deletion. So now we have 18 rows only. That is one problem. So mean median mode we saw, list-wise deletion we saw. Third way of imputing your missing data is called predictive imputation. You have to search for something known as mice imputation as well. This is one category of predictive imputation. But what we do in predictive imputation is, let me try to create the missing data one more time for demo purpose. What we do is we simply try to predict this using other features. Okay. And then we try to fill this value. So what we are trying to do here, if you see, we are saying can an imputer, near number of neighbors 3, and then df age salary is equal to can an imputer fit transform age salary. So what we are doing, we are trying to fit and transform. We are trying to predict using k nearest neighbors. So if we do this right, then you will see that in df the age and salary will get predicted, and we will not have any missing data now. So if I do df dot head 10, right, you will not see any NaN here because that has been predicted. So here we are predicting. Pros and cons. More accurate is pros, and cons is computationally intensive, may add noise with high variance. Okay. So this is about your KNN kind of imputation or any kind of predictive imputation. Let us move to the fourth preprocessing technique in this category, and that is known as, you can add a column here saying for which records your data is missing. For example, let me recreate the missing data one more time. And what I mean to say here is, there can be a reason why data is missing. For example, if data is missing here, there can be a reason. So if I want my model to learn that or know that reason, right? What I will do is I will simply create an additional column where I will say that where my age is missing. Okay. And that I will capture. For example, age is missing here. So I'm capturing this in an age missing column. Now this age missing column, I want to use for my predictive modeling or data analysis or any purpose. And I want to establish the relation why age is missing. Fine. So this is not very actually removing the value, but we are trying to gather some more information from the data. So four different techniques when you have a situation of missing data. All pros and cons I discussed with you. Let's move on to the next situation. Common situation. Next situation is when you have categorical variable in your data. So in our data, right, if you see here, there are a lot of categorical variable. For example, city, gender, etc. When you have categorical variable, what are the things you can do? So if you come here, right, first way is called level encoding. What is the meaning of level encoding? It's very simple. If I run this, right, you will see that I'm running the level encoding on gender column. So you will see that in gender, we have here male and female. But after running level encoding, right, you will see that male and female is being converted to 0 and 1. So this is simple and specificient and implies ordinal relationship, which may mislead models. So here ordinal relationship is there. Okay. So for example, rank, or for example, any categorical variable where there is a ordinal relationship, but in male and female there is no such ordinal relationship. So this is not giving a very good representation of the data, but still this is one way of level encoding. What you do here, you simply go and assign a number 0, 1, 2 like that to your categorical features. This is called label encoding. First way, pros and cons written here. Second way, if you are in this situation, right? If you are in this situation, what you can do is you can simply create dummy variable. The meaning of dummy variables is, here the city is San Francisco, New York, Los Angeles, San Francisco. If I create dummy variable, right, how it will look like is, I have just run this, so it was showing already, but city New York, it will become false, 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 true, true, true. City San Francisco, it will become true, 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 false, false, false. So what the meaning of this is, one column is getting expanded into two columns, and we are getting true, false, true, false. So this is called dummyfying or one hot encoding. This is another technique. Pros and cons. Pros is great for non-ordinal categories, maintains all category information, and cons is increased dimensionality, particularly with many unique values. As you can see, it is increasing the dimensions, right? So that is one con. What is the third thing you can do when you want to work with categorical data? So I'm recreating the data again. So if you have ordinal data, right, then what you can do is you can do something like ordinal encoding. The meaning of this is, If I want to map New York to 1, San Francisco to 2, and Los Angeles to 3, what I can do is, if I know the order, if I know what order I want to maintain, I can simply go and I can say that, hey, in my city column, wherever you see New York, say that 1. Wherever you see San Francisco, say that 2. Wherever you see Los Angeles, say that 3. And I can have my data like this. So, 3 different ways till now. First is label encoding, simply 0 1 without, uh, it does not necessarily, it is just kind of labeling your encoding. Okay. One hot encoding is basically dummifying. Ordinal encoding is you are explicitly saying that maintain this order. Fine. If your data is not having a natural order and you are doing a label encoding, then you are misleading your model. Okay. If you know that your model, your data is having a natural hierarchy, natural order, ordinal data, right? Then I recommend you go for ordinal encoding because you know there is an inherent order. Fine. Next is target encoding. What is the meaning of target encoding? The meaning of target encoding is go to my categorical variable and whatever value is there, right? So if you see there, here, right, mean target is equal to df dot group by city purchased mean. Go to my some other column, take the mean based on that categorical feature and put it in that feature. For example, if I run this, right, in all the San Francisco, the value will be 0.333 and so on and so forth. So for one city, right, value will be 1 because what is this is a mean of some other column. Okay. So what the assumption here is, put the values in the categorical column, imagining or assuming that the behavior will be same as compared to some other column. So this is basically target encoding. What is pros and cons? Useful for high cardinality feature and can cause data leakage if target encoding is not done properly. So data leakage will be there because two columns are kind of related. Okay. So how many ways we have seen in categorical encoding? Level encoding, one hot encoding, ordinal encoding, target encoding. You can scroll down, up and down, go back in the video and see pros and cons. Next situation is when you need to scale features. So many times you will have different kinds of data in your model. One can be on some other scale, other can be on some other scale, right? If you want to scale, the first way is standard scaler. What is the meaning of standard scaler? It will bring your data mean 0 and variance 1. It works well on normally distributed data, suitable for many models, but it is sensitive to outliers. Okay. What I'm doing here, I'm simply going and scaling my age and salary column. So as you can see, previously age was integers. Now it has become decimal between 0 to 1. Mean 0 and variance 1. And salary is also mean 0 and variance 1 kind of scenario. Okay, this is first approach. The other approach is min max scalar. Another approach is robust scalar. So let's see min max scalar. I'm recreating the data one more time to show you min max scalar. So in min max scalar, what happens is your data will be shifted in the range of 0 to 1. Here the range of -1 to 1 actually in this category. But here it will be 0 to 1 and keeps all data between 0 to 1, ideal for distance based model, can distort data distribution, especially with extreme outliers, pros and cons. Okay. So if I run this, right, you will see that all values are between 0 to 1. And it is basically the formula for min max scalar is x minus x mean by x max minus x mean. So basically in your column, right, you go and you see that fit in that formula and whatever the result you put it here. So this is another technique and pros and cons are here. I will recreate the data and show you one more technique that is known as robust scalar. So what does robust scalar do is uses median and interquartile range robust to outliers. So more robust to outlier because it uses median and IQR doesn't work well for normal distribution. If your data is normally distributed, right, don't do this. But if your data has outliers, if you don't want to take a risk of what will happen to your values when you do scaling, right, then you go and do robust scaling. And when you do that, right, internally it uses IQR and median, and this is your scaled values. So three things in this category: robust outlier, min max outlier, and standard robust scalar, min max scalar, and standard scalar. Just try to see pros and cons in these categories. Next is talking of outliers, right? When you have outliers in your data, what all you can do? So one method which many of you might be knowing is simple and effective for mild outliers is IQR method. So you simply see Q1, Q3, you see the IQR, you set the lower boundary, upper boundary. Anything which is more than upper boundary, you just make it upper boundary. Anything which is less than lower boundary, you just make it lower boundary. That is how you treat the outlier. This is basically simple, effective, well-known, and may overlay reduction variation if there are many extreme outliers. So if there are many outliers, right, then there will be a problem. Otherwise, normally it's work good. So in some column, if outlier is there, it will work good. I'm recreating the data and trying to show you Z-score method. What Z-score method does is, it will simply see which is more than 3 standard deviations away. Okay. So if you see here, right, DF score is equal to stats dot Z score of DF salary. So it is calculating Z score for every observation. Wherever Z score is greater than 3, right, it is simply making it NAN. So it is considering that as an outlier and making that NAN. So Z score method is good for normally distributed data, because in normally distributed data, you will have the meaning of outlier is fine if you are using Z score. Okay. If not, then this may not be a suitable method for that. I'm recreating the data again. And here, median replacement for outlier is another technique. This is a safer technique, keeps distribution shape intact, useful for capping isn't feasible, may distort that data if outlier represent real phenomena. So what I'm doing here is I'm playing safe. I'm simply replacing outlier with median. What can happen is sometimes if the outlier has some meaning, right, and you are replacing with median, then you are not doing justice to the data. Okay. So same funda here. I am calculating median. Wherever I see there is an outlier, I simply replace with median. Okay. So, so this is a package problem. Don't bother much about it. So we can import the package and this will run. And what we can do is, so here package is imported. So let me try to run this, and run this. It will run. Okay. So in this category, right, outlier category, what all we have seen? We have seen normal IQR method, we have seen Z-score method, and we have seen median replacement method. Pros and cons you can see as usual. Last but not the least, feature engineering, right? So how can you create a new feature based on salary? Suppose this is your data and you have the salary here. One technique that you can use is called binning. This is simplified continuous feature, useful in nonlinear, can lose data granularity, potentially reducing model accuracy. So if I run this right, what will happen is I'm creating a new income level column based on this salary, and this will have medium, low income, medium income, high income, like that. Okay. Basically, I'm bucketing the salary column here, and this method is called binning, and this is one of the most known, well-known feature engineering technique. Okay. So creating a new feature based on this salary and potentially reducing model accuracy. Now, another technique I want to show here is known as polynomial features. So nothing fancy here. You simply go and create the higher order value for your features. So age is this, you create age square. Salary is this, you create salary square. Age and salary are here, you create age salary. So this is another technique that we use. We call this polynomial features. Okay. So feature engineering is a vast topic. I am just showing you a few. But in total, I have showed you 15, 16 data pre-processing techniques. When you have data to work, you are bound to have categorical variable. You will definitely have missing data. You will definitely have outliers, and you will definitely have some kind of features to create, some kind of levels to encode, right? So all these things, you can keep it with you handy and you can use it wherever you want. If you like this kind of video, please give me a thumbs up and motivate me. See you all in the next video. Wherever you are, stay safe and take care.